Textual inversions can be trained for free on Google Colab. You may have played around with them in Automatic 1111, but you need a premium Google Colab plan to use it there. To get started, I have a link to the Google Colab notebook here in the description. I also have a dataset consisting of 6 photos of my cat, Mia, here with the labels. Although the original Stable Diffusion 1.5 model has probably never seen my cat before, it's probably seen other tabby cats like her, which is a perfect exercise for textual inversion to try to fit to. For best results, please label everything significant in each photo except for the subject, like I have here. So let's look at some examples of my cat Mia here. So let's open this. Actually, I want to open it with code because it's easier to see the labels here. So that one has a white blanket. This this photo here has a white blanket. Let's look at this one. Here I have she's on top of a washer dryer with a space heater. So label here says washer dryer space heater. Notice I did not have any labels for the cat, and this is by design because that's the subject. So now let's take a look at the training parameters. You'll want to name your textual inversion in the TI name field, preferably something that isn't already taken like a common word or name. So I probably don't want to name a Nia. Probably don't want to name a cat or something, but let's name it something like this. CTMMA. So this is something that Stable Diffusion probably does not know. So that's probably a safe bet here. As for class name, you can leave it as the star, though if what you're training it on is an object that's very common. I highly recommend you change it to that, as that could also speed up the training. Here, I'm going to change it to cat. If you're training it on a person, which is also a common subject, you want to change that to man, woman, or person, depending on their gender. For vectors, I'd like to keep it at about 1 less than the number of images I have. So I have 6 images here. I'm going to keep it at 5 vectors. So in general, I'd say there's really no hard and fast rule, but if you have less than 10 images, keep it at the number of images minus 1. For over 10, I'd probably keep it at 10 and maybe bump it up to about 16 for over 100 images. Most words in your Stable Diffusion prompt use 1 or 2 tokens. And the more complex your subject, the more tokens you'd want to use. But if you use too many, the model will likely overfit. As for epochs, 1400 is a good place to start and will take a little over 2 hours to train, maybe a total of 2.5 hours, including the initial setup time. You don't want to have too many epochs on a free Colab, as you would generally get a maximum of 3.5 or so hours if you haven't used it recently, less if you have. If you have less than 6 images, make sure to decrease the number in the batch size to the number of images. But if you have more, leave it at 6, or you're going to run out of memory. And learning rate is dependent on your data set, but this number is a good one to start with. And for very large data sets, you might want to bump the gradient accumulation up. And if you run out of memory here, you may also want to bump the batch size down, as gradient accumulation also increases memory usage. If your gradient accumulation is 2, but the batch size is 6, your effective batch size is 2 times 6, or 12, but you're not going to be able to use a base 12 batch size here with a free Colab, but you can if you use gradient accumulation. information. It has the same effect as training with a batch size of 12. As for Hugging Face repo, let's just keep it at the default base Stable Diffusion 1.5, though some people may prefer another pre-trained model, especially for anime. Note that this notebook only supports Stable Diffusion 1.5 class models, though I've heard of people training them in SDXL and may make a video on those later if it's viable in Colab. Once we have all of our parameters set, we want Colab to install dependencies. Well, right now, let me just start running this runtime. So make sure you also hit change runtime type and move this up to a T4 GPU. And these are not gonna, the A100 and L4 are not gonna be available in your free Colab. So just use the T4 here. And then let's hit runtime run all. And there's going to be a dialog that pops up asking you to mount your Google Drive. Once this mounting completes here, yes, permit your notebook to access the Google Drive file. So click connect to Google Drive. And here's me, and then I hit continue, and you can just select all here and continue. So that's going to load your settings, and then here it's the second cell. Once this one finishes, it's going to start installing your dependencies. And while your dependencies are being installed, something else that came up to my attention here. And yes, you may be wondering why I'm using Stable Diffusion 1.5 and Textual Inversions, even though we've got SDXL, Stable Diffusion 3.5, and Flux out today. First, this version is much easier to train, both time and resource-wise. And you can still use it for inpainting if you've created an image in SDXL, Flux, Stable Diffusion 3.5, etc., or use a detailer to, say, swap out the faces. Second of all, LoRAs don't work really well when you've got many of them stacked together compared to textual inversion. Usually, from my experience, you can stack maybe 2 to 3 LoRAs before the images become really distorted. While if you have a textual inversion, that frees you a slot for LoRA. So now the dependencies have been installed, and here we're at the training cell. So I'm going to pause the video, and we're going to come back once the training is finished and look at how it did. All right, so we're back. Now you can see we only got 6 epochs left before our training finishes. And it's taken about a little over 2 hours for this training. And let's look at the memory profile here. And we're barely getting by at 14.3 gigabytes of VRAM out of 15 allocated to us. So you would probably want to drop this down to 5, the batch size of 5 if you're using a gradient accumulation over 1. So now it finishes, and I just want to show you this cool thing with the shutdown cell here. I'll automatically remove these artifacts in here, and okay, well, actually, we miswrote this one, so let's just have this shutdown run. So it'll basically remove these artifacts, these checkpoint directories here, where you have like that are useful if you need to resume training. Let's say you run out of time here and you need to resume the training. This notebook would do that automatically, assuming you pick the same directory. So now this also shuts down your notebook with a 5-minute wait here. which allows the model files to be transferred to your Google Drive. And at this point, we can download this file. You want to download the file called learnembeds.safetensors. So let's download that. And now you will want to save it. I saved it in my downloads folder. You will want to rename it as this, CTMMA, which was the name of our textual inversion. So let me do that. I will rename this. I will cut and paste it into my Stable Diffusion directory. Here, go to embeddings and paste it here. And now let's test it out. You want to name it CTMMA. That's what we called it. So I'm using realistic vision as my base model. And here's a generic cat that it generated. Sometimes you may need to input the keyword cat in there as well. And let's see here. And there we go. That's my cat Mia. And she's on a sofa seat. So let's say maybe let's have her on a cat tree. I don't know. Sometimes these you may need to tweak these prompts around a bit to get the right results. Okay, she's on the seat here. I mean, it doesn't always work. Let's say on a bed. And that's kind of a cat bed. You can say things like bed, potted plant, and then let's say phone. Yeah, I mean, you need to adjust the prompts around a bit, but basically, you can see here, that's a picture of my cat Mia, and we can compare that with the picture of her that I trained her on. And these are some of the pictures that I trained her on versus the picture that you have in that's generated by Stable Diffusion here. So it looks pretty similar. Well, we can also try, let's see if we just try to generate a tabby cat without our textual inversion. You probably would get a different tabby cat. Yeah, that looks a little different than me. Yeah. So there you go. Keep in mind these notebooks may not always work, especially in the future if you're watching this video in, say, year 2030 or so. But hopefully we have much better models then and much better GPUs on Google Colab. But sometimes Colab changes their default environment a bit, and this notebook may need to be tweaked. So if that's the case, leave a comment, and I will look at it. And in the meantime, if you enjoyed this video, please subscribe to my channel, INTP Programmer. Thank you very much.